Okay, this goes with Student Companion Model and Solve 1-3. And Latoya wants to find the center of the back wall. And they're showing us in the diagram that AB is where the back wall is at. So one thing she can do is count the distance from A to B. So if we count, we get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Half of 11 is 5.5. So we can add 5.5 to the x-coordinate of A, which is 1, and get 6.5. Or we could subtract 5.5 from the x-coordinate of B, and 11 take away 5.5 would also give us 6.5. And since there's no change in y for this problem, since the back wall, basically the y coordinates are 10 for both of those, basically the midpoint's going to be at 6.5, 10 in terms of the axis system. For part B, Latoya wants to find the midpoint between the chairs. So to do that, what she needs to do is find half the distance of the x's and half the distance of the y's. Well, the average of the x's and the average of the y's. So we need to find the x and the y coordinate of C and the x and the y coordinate of D. C is at 9, 9. D is at 11, 5. So 9 plus 11 is 20, and the x's, 20 divided by 2 is 10. And for the y coordinates, we have 9 and 5. That gives 14. Half of that is going to be 7. So 10, 7 is going to be the coordinate of the midpoint. Let's move on to example 1. In example 1, we want to find the midpoint of the segment with the given endpoints. Point C is at -2, 5. Point D is at 8, -12. So usually I try to draw a segment and represent the situation. And we want to find the midpoint. So we're going to add the x's and divide by 2. We're going to add the y's and divide by 2. Remember the midpoint formula? x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. And that's going to give us our midpoint for the x-coordinate and our midpoint for the y-coordinate. So we need to add the x's, 8 plus a -2, or -2 plus 8, divided by 2. And we need to also find the y-coordinate of the midpoint, which is going to be 5 plus -12 divided by 2.
In the eastern part of the United States because...
Okay, let's look at part B. So a good way to do this is always try to sketch a diagram, but for this one, we'll just do the formula, the way that they give it to us. So I'm going to copy the points down here. So we have 2.5, -7 for 1 point. That's our E. And our F point is at -6.2 and -3.8. So I can see the problem here is going to be you're going to be subtracting negatives, having to do plus opposite, and also you got decimals involved. So it's going to make the numbers a little bit trickier. So what I want to do is just set up the midpoint formula. Let me make this a little bit thicker. So I want to set up the midpoint formula. So M, which is midpoint in terms of x and y, is equal to the sum of the x's square over 2 plus the sum of the y's over 2. And these little sub numbers just kind of mean they're coming from one set or the other. So I'm going to let this be my 1 set. I'm going to let this be my 2 set. So I'm going to plug the numbers in. So the x from my 1 set is 2.5 plus the x from my 2 set is negative 6.2. Well, it's going to be over 2. That's going to give me the x coordinate of my midpoint. And then the y coordinate of my midpoint is going to be, with this next part, I'm going to take the y from my first one, which is negative 7, plus the y from my second one, which is negative 3.8. That's going to be divided by 2. So that needs to be simplified. So negative 2.5 and 6.2, it's going to be negative because negative is larger. And if I do the difference of 2.5 and 6.2, I think I get 3.7. This would be negative 3.7. And if I look at these two added together, these are both negatives, are being added together, so the sign stays the same, they stay negative, and this is going to give me 10.8. So there we have the midpoint of EF. So midpoint EF, I want to use notation, is at negative 3.7 and negative 10.8. Up here, our answer was negative 3, negative 3.5. Let's look at the example 2, try it. Okay, for the example 2, try it, we want to see what we can find out by connecting the dots. No, we don't want to connect dots for this one. Never mind. No, actually, for this one, what we want to do is, it says that we want to find the coordinates of each point described. So we want 7/3 of AB. We want to partition this segment. Now, let me see what we're going to do for the coordinates here of AB. They're not really giving us an AB, are they? So let's look. So if I draw this segment AB, now if it's in the ratio of 7 parts to 3 parts, you got to remember there's 10 total parts. Let's look over here. 4/5 of the way from A to B, there's actually 9 total parts. That's important. So this one point needs to be 7 parts out of 10 along the way. Coming back, it needs to be 3 parts out of 10. So this is like a 7/10, 3/10, just like this one is 4/5. So this also could have been said to be in the ratio of 4 to 3 or 4 to 5, which would be exactly the same thing. 4 parts out of 9, 5 parts out of 9. So 4/5 of the way from B to A, it's going to kind of be back a little bit. Now, I must assume that for this example 2, that they're giving us the coordinates from example 2. So I need to look back at example 2 in our note. Okay, so here's our example 2 in our notes page, our presentation page. And notice that the coordinates of A are at 3, negative 4. And the coordinates of B are at 13, 11. So 3, negative 4, and 13, 11 are the coordinates. Now let me double check that. 13, 11, 3, negative 4. Okay, so for part A, we want the ratio of 7 to 3, so we want really 7/10 of the way from A to B. So if this was 10 parts, we want 7 of those parts. We also want 7/10 of the way from the y coordinate that goes with A to B. So what we could do is kind of think about this distance here, which is our x distance. And our x distance is the difference of the x's. We're going from 13 to 3, which is a distance of 10 units. And we could also look at our y distance. Let me change colors up on that. Our y distance here, we change colors, which is from 10 to -4. Now, 11 to -4 rather. 11 to 0 is 11, to -4 makes 15. So this is 15 units of distance. So the x-coordinate of our 7/10 of the waypoint is going to be 7/10 times 10, which is going to be 70 over 10, which is 7. Or you could look at the 10s as cross-canceling. And it's going to be 7 more than the starting point. So the starting point was 3. That's going to give us the x-coordinate equal to 10. 7 plus 3 is 10. Do the same thing for the y distance here. We're going from 11 down to -4, which is a distance of 15. And we also want 7/10 of the distance between those points, which is 7/10 of 15. Now 7 times 15 is going to be 105, and we have 105 over 10. 10 goes into 105 10 times with half left over, or 0.5, so this is going to be 10.5. So we need to go up 10.5. So from -4 added with 10.5 gives us 6.5. That's going to be our y coordinate. So our new x coordinate that we need for the 7/10 way is 10 over from 3, which gives us, or which is 7 over from 3, which gives us 10. And our y coordinate is going to be 7/10 up from -4, and it's going to be 7/10 of this 15 difference, which comes out to be 6.5. So that's going to be our coordinates. Our coordinates are going to be at 10, 6.5. So a little bit tricky, but if you think it through, it's doable. Now let's look at the next one. 4/5 of the way from B to A. So now A again is at, let's write it down. A is in 3, -4. And B is at 1311. And this time we want 4/5 of the way between B and A. So we're going to be moving from B. So you're going to notice there's 9 total parts. 4/5 of the way, 4/5 of those 9 total parts is basically going to be 4/5 times, there's going to be 4 out of 9. And so we want to find our x distance. Our x distance is going from 13 to 3, which is 10 units. And we want to find our y distance. Our y distance is going from 11 to -4, which again is 11 units to 0, another 4 from 0 to -4, gives us 15 units of distance. And we want 4/9 of those distances. So we want 4/9 times 10 for the x's, and we want 4/9 times 15 for the y's. Let's see, nothing really cross cancels here. We have 40 over 9. Now 40 over 9, 9 times 4 is 36 with 4 left over. So it's 4 and 4/9. And it didn't say to say it, do a decimal. So we have 4 and 4/9 there. And 4 times, well, we can simplify this a little bit. 3 comes out of the 9, 3 comes out of the 5. Out of the 15 gives us 5. This gives us 20 over 3. So I simplified a little bit earlier. That's going to be 6 2/3. Now here's the trick from this one. We're going from B to A. We want that distance from B to A. So with the x-coordinate of B, we need to come back 4 and 4/9. So we have to do 13 take away 4 and 4/9. So I can already see that it would have been better to stay in fractions instead of mixed numbers, as I was using a fraction calculator. So on the other side, I'm just going to basically use the fraction. So this was 4/9 of, multiplied it out, this would have been 60/9. And we're going to do 11 take away 60/9. Let's see what we get. So 13 take away 4 is going to be 9. 9 take away another 4/9 is going to give, take 10 off of 4. That's going to be, well, we're dealing with 9s. So 4 out of 9 subtracted from 9 out of 9 gives us 5 out of 9. So we're going to end up with 9. We're going to end up with 8 and 5/9 for the x-coordinate. And for the y-coordinate, since we're dealing with 9s as denominators, we could look at 11 as 99 over 9, because 99 over 9 is the same as 11. 99 over 9 take away 60 over 9 is 39 over 9. So we have 8 and 5/9 and 39/9. They should, here we have one in improper fraction, one in mixed numbers. Let's do it both ways. So the mixed number way for this one would be 8 and 5/9. And 9 goes into 39 4 times, with 3 left over. 36 and 3 makes 39. And 3/9 is 1/3. So there's the mixed number location of the coordinate. Now let's go for the improper fraction version. 9 times 8 is 72, plus 5 makes 77/9. And we have 39/9. So here we have the improper fraction version. And both of these are the same thing. If I want to check it, 9 times 8 is 72. There's 5 left over. Gives me the 5/9. And over here, we've got 9 goes into 39 4 times with 3 left over, which gives us the 1/3. So either one of these would be good answers for part B. Okay, let's look at example TryIt 3. Derive the distance formula. Tavon claims that distance equals the difference of the x's squared plus the difference of the y squared. How can also be used to find the distance between 2 points? Is he correct? Explain. Well, let's look. To me, the distance formula is basically the same thing, but let's find 2 points. Let's do this in general. So let's call this point x, and its coordinates are x1, y1. Let's call it point x1. Let's call this point x. No, let's just call this point x. Let's call this point y. And its coordinates are going to be x2, y2. So x can be, if x is 10 and y is 5, we got 10, 5. Here, if x is 34 and y is 15, basically we just kind of represent it generally. Now, let's look at this. Let's pretend that we have a right triangle, and we're going to kind of depend on the Pythagorean theorem here. So the Pythagorean theorem deals with the difference of the y's, or really the y distance plus the x distance squared, and take the square root, gives us the distance, which is the hypotenuse. And the hypotenuse in this case is the distance between those two numbers. So how can we represent the difference of the y's? y2 minus y1. Over here, how can we represent the distance of the x's? This is my x2 point. This is my x1 point. I'm doing x2, take away x1. I'm doing the Pythagorean theorem. A squared plus b squared. C squared is equal to that. You're going to take the square root. So C is going to be the square root of a squared plus b squared. A squared is x2 weight minus x1 squared plus b squared is y2 minus y1 squared. And we're taking the square root. So we can demonstrate with two general points that the distance formula is the difference of the x's squared of your 2 points added to the difference of your y squared added to the other point, and you're going to end up taking the square root of that. So yes, the distance formula can be used to find the distance between 2 points. It's the same thing. Okay, let's look at the next one. We want to find the distance. How far does the shortstop need to throw the ball? So here's the shortstop. He wants to throw the ball to first base. So he's going to throw the ball to first base. And he wants to find this distance and round to the nearest tenth of a foot. So I'm just going to work this out, but since I'm not using a calculator, I'll leave it to you to round to the nearest tenth of a foot unless it ends up an even number. So using what we talked about with the distance formula, let's find the coordinates of where the shortstop's at. So the shortstop is over 5 and up 10. So he's at 5'10". The first baseman is at over 10 up 0. He's at 10'0". And we want to find the distance between these. So we're going to be doing the distance is equal to the square root of the difference of the x's squared, 5 take away 10 squared, plus the difference of the y squared, which is 10 take away 0 squared. So 5 take away 10 squared is 5 plus a negative 10, which is negative 5, but negative 5 squared is negative 5 times negative 5. That gives me 25. Looking at the difference of the y squared, we have 10 take away 0 squared, which is 100. So we're looking at the distance for the shortstop to throw from where he got the ball to first base. It's going to be the square root of 125. Now that's an exact distance, and it's going to be 11 point something. You can use a calculator and abbreviate it. If you want full credit, you need to have the correct answer to the nearest tenth of a foot. So be warned. Okay, let's move on. And that's all of our examples. We're over to the do you understand, do you know house.